Okay, so thanks for coming. My name is Charlie Greenbacker. That's Joe Furter, my coworker. And so a while back when Jeff and Wes were talking to me and Liz about doing a joint meetup between the graph database folks and the NLP folks, we were trying to come up with an idea of what to talk about. We were thinking, well, maybe we'll do some kind of side project that combines the two. And we're like, well, that's a lot of work, right? And I figured, well, hey, oh my gosh, you know, I'm actually doing something at work that combines NLP and graph databases, so that's perfect. We can just talk about that. So what we're going to be talking about is an open source project called Lumify, and the NLP and graph database aspects of that. So this is quickly what we're going to cover, do some introductions. Joe will actually introduce himself in his portion. I'll give kind of an overview of Lumify as a project, sort of what it's all about, the big picture. And then the two things we're going to focus on this evening are the NLP side of things, natural language processing, which I'll cover, and Joe will talk about how we're using graph databases in Lumify. So just a few words about myself. Charlie Greenbacker, that's my Twitter handle. I'm a data scientist, which is like a made-up term for someone who does, you know, all these different things: machine learning, statistical analysis, NLP, data mining, whatever. Unlike Dr. Peter Venkman, who has degrees in both parapsychology and psychology, I never finished my PhD. All my degrees are computer science, and I was a computer science PhD student. And then this happened, right? So my wife and I got pregnant. Real world happened, so I had to get a real job. Baby number 2 is coming in 8 weeks, so if my phone starts ringing, I'll have to... Thank you. So my phone starts ringing, I'll have to head for the exit. The company that Joe and I work for is called Altamira, based in Tyson's Corner, an open source technology company supporting mostly federal agencies in the defense and national security space. Altamira was actually formed late 2012, early 2013, when 2 different companies were purchased by the same private equity partnership. So Near Infinity Corporation, who Joe worked for, you may have heard of. Another company, Enrich Corporation, were purchased by the same equity partnership, who merged them together, and the merged company is called Altamira. So that's our cool software lab where we do demos and stuff. But what we're here to talk about today is a specific project that we're doing called Lumify. So the kind of definition of Lumify is it's an open source, which means open source software, as in go to GitHub, download it, play with it. It's a platform for big data analysis and visualization. And we'll get into what we mean by that. Built by engineers in Altamira, but we welcome contributions from the open source community, anyone who wants to play along. And again, it's from Altamira. So kind of the 5 high-level concepts. This is kind of the glossary for what Joe and I are going to be talking about. These are the things you have to know or keep in your cache for what we're going to be talking about. So the first thing is the ontology. That's kind of the data model. So any of the structure for the things that you want to track and analyze in your data, okay? Lumify doesn't prescribe any specific ontology. The user organization, each organization will sort of provide their own. Right now we support OWL, the OWL specification, so you provide an OWL file. Is that working? Yeah. That sort of defines the different types of things that you want to track. And Lumify will kind of, we say, saturate around that. So you provide your own ontology. Entities are any things that you want to represent in Lumify, so people, places, events, organizations, whatever, kind of like the nouns, and those are going to be essentially the edges, or I'm sorry, the nodes of the vertices in the graph. Relationships are any links between 2 entities. So as it says, a person is a leader of an organization, or a person works for an organization, or 2 people are siblings. They define the connections between the entities. So these are the edges kind of in the graph. Properties are any sort of metadata about your data, so information about your entities, information about your relationships, different sort of for people it can be dates of birth, eye color, whatever. For relationships it can be like the beginning and end date, like you work for a company from this date to this date, that sort of thing. And then the graph is kind of the collection of all of those instances of entities and relationships. So the ontology is kind of like the abstract definition, where it defines the types of entities and relationships. And the graph is the collection of all the instances in your data store, okay? So this is where I'm actually going to switch to a demo. So hopefully everything's working properly. So Lumify is a web application, and right now this demo is running on AWS. So I just log in here, everything looks okay. This kind of white space all in the middle is the workspace where you do all of your work, it's where you do your analysis, do your visualization, that sort of thing. Along the left-hand side are a bunch of tools, different things for me to play with the data. So the data that I have loaded in here is about threat finance, specifically drug trafficking, Mexican drug cartels, essentially. So if I do a quick wildcard search, and hopefully people in the back can see, or should I zoom in a little bit? Is that okay?
We can also change the lighting.
Zoom in. How about that? Is that better? Okay. So this just shows the data that I currently have in the system. Some raw documents here that were ingested, and we'll talk about what happens with that. And then all kinds of entities that were pulled out either by the machine itself or by a human user coming along and adding things. And this sort of starts to get where the NLPs come along, but it'll all tie together in the end. So I don't know if you've been following the news or know much about Mexican drug cartels, but this big kingpin goes by the nickname of El Chapo, was the head of this the Sinaloa drug cartel, one of the biggest Mexican drug cartels. He was recently apprehended by Mexican authorities for the first time, or the second time. For the first time in the 90s, he broke out of jail by hiding in a laundry cart, like right out of the movies. Okay. Hopefully he stays in jail for a little bit longer this time. So hypothetically, we're an analyst, and we're trying to figure out, okay, what happens to this organization now that the sort of leader is removed? So maybe our entry point into it is by looking at the number 2, who goes by the nickname of El Mayo. You know, just like the mafia, they have these nicknames. See all the different things that are associated with El Mayo, including one person entity. So what I can do is grab that entity, throw that on my graph here. I'll sort of use that as the beginning of my investigation. Grab him, right-click on him, and maybe I want to say, okay, well, I can click on him and get a baseball card view of all the different pieces of information we have about this individual. This is all unclassified data collected from open sources, from the web, treasury.gov, state.gov, all that sort of thing, law enforcement websites. I can click on him and say, show me all the different organizations that he's known to be connected to. Right now, we only know for sure that he's connected to the Sinaloa cartel, because these guys, again, just like the mafia, they create all these layers of obfuscation so they can hide the illicit activity, money laundering, that sort of thing. So that's not the end of our investigation. We can go look at some more things. We can say, show me all the related people. So now we see all the different people that are known associates of El Mayo. Again, I can click on them, bring up their baseball card to view if there's any information about them. If there's a picture, the picture comes up. For this guy, it says that he actually works for 2 people. So he doesn't just work for El Mayo. He works for Joaquin Guzman Loera, who actually is El Chapo, who I was just talking about before. So if I want, I can grab him, throw him onto the graph here. And Lumify will then draw any connections that it knows about to any entities that are already on my graph here. If I click on this woman, I see, oh my gosh, she runs like 24 different companies. Well, isn't that interesting? Maybe I want to dig a little deeper there. Right click on her, say add related organizations, and I see all those companies that she runs, add related people. And I'm starting to build up this graph view of all these different things that I have information about. And at this point, all the data has come from structured data. So we have information like leadership profiles, company ownership. You know, when individuals get designated by the State Department as known drug kingpins, and all their information gets published for law enforcement to like keep an eye out and all that sort of thing. So we use all that, load it up. It tells us about the companies that they run. You know, they set up all these front companies to again hide the money laundering, that sort of thing. All their known associates. We take all that and automatically build all these edges between all these people, and that's where we get all the data from so far. So at this point, I can ask some questions about the graph right here. Maybe I want to ask, how is El Chapo connected to this company right here? So I draw a link between them and I say find path, and it's going to say I can't find anything just yet. Up to 2 hops. I could increase the number of hops. With a larger graph, the higher you go, it gets more computationally expensive. You start to get to more spurious links because of 6 degrees of cut and bacon. But maybe a piece of information comes along and tells me that this guy right here, Jose Guadalupe, he actually works for that company. So I can just go and draw a connection there and connect them and say, I got a couple different options. This comes from the ontology. I'll say he works at that company, add the connection. And now if I go back, I can ask the same question before, how was El Chapo connected to that company? And there it goes, it finds the path between them. So I got A is connected to B from one source or one analyst. Another user comes along and says B is connected to C from another piece of information. And then user number 3 can come along and say how is connected, A is connected to C, and it shows it to you right there. So far, everything I've been showing is structured data. but we're here to talk about half of the conversation is going to be NLP. Half the faces in this room are familiar, so I'm figuring you guys want to hear about NLP. So I'll go in and I'll search for Chapo, who was the leader we were just hearing about a moment ago. And I see all the different documents that he's mentioned in, okay? So I can pull up one here. Whoops. Pull up one here. This one. Let me close that. Open this up a little wider. And there's a couple things going on in this sort of preview of the text. So things that are underlined and just sort of dotted underlined, like this right here, are entities that were found by an entity extractor, people, places, organizations, that sort of thing. But we don't trust the machine enough to do all of it automatically, so it just kind of highlights those in the text, things that it thinks it's found. Me as the user, as a human who's really slow but really smart, whereas the machine is really dumb but really fast, I come along and say, okay, this name that you underlined, it is in fact a person, so I'll say I want to resolve that to an actual entity. I get some options on things that match that name, including the guy that we care about, Joaquin Guzman-Laura. So I'll click on that. Here I could add a classification or some sort of access control for this individual, and Joe will talk about what powers all that. And then I'll say resolved as existing, and now I get, it's no longer just underlined, but it's highlighted, so now this is an actual resolved entity. So now this document has been definitively linked to that dude we were just looking at a second ago. Other things are already bold and underlined, like locations. Another tool I'll talk about in a second called Claven doesn't just do the extraction for geospatial locations, cities, countries, mountain, rivers, whatever. It'll take it a step further and actually link it to a real world entity, right? So it'll tell you, it'll take a location name and link it to a lat long, population, whatever, and it sort of figures out that disambiguation step of which Springfield you're talking about. And I'll get into all about how that works in a second. So at this point, I can do a lot of different things. For example, I can look at Chapo again, go into a different document. Let's see. Here's one that's sort of a baseball card that's put out, I think, by the State Department. I can click here. I can look at the original document as it was ingested by Lumify. These sort of, again, information that they put out. Like there's a reward, or there was a reward out for this guy before he was apprehended. If I go in here, I see some information it's providing. So it's giving me his birth date right here. What I'm actually going to do is copy and paste that. So I'm just going to copy just that snippet of text. I'll bring up Chapo's sort of profile view, add a property, go to birthday. I'm going to copy and paste that in. If you remember, I'd only copied just the date. The Lumify remembers inside the system where I got it from. So it's making the connection back to that source document. So it's not just this plain string, it's a reference back to the source of where I got it from. I still have to go in and add the date by hand. We haven't implemented the date parser yet, that's low-hanging fruit. But I'll add that, and now I see, I just added this birthday for El Chapo. I see where I got it from, that sort of thing. I can click on the audit trail and get every single thing that's ever been done to this entity, either by a system process or by a user, by anything. So yeah, that's kind of in a nutshell. I can go into some of the stuff we do with image analysis and video analysis and geospatial stuff, but maybe we can talk about that after the talk, because I want to focus more on the NLP stuff that we're doing here. We do some pretty cool stuff with live shared workspaces where if somebody else was logged into the system and I can share my workspace with you, we can collaborate in real time, kind of like Google Docs. And as you change and add things on my graph, I'll see it change here in real time, which is kind of cool. But let me switch back to the slides here and talk more about what we're doing actually in Lumify. So just a few words briefly on the kind of intended user base for Lumify. As you might imagine, yes, we are in DC, right? So we imagine that perhaps an intelligence analyst might want to use Lumify to do some investigation, kind of like they would use a tool like Palantir, if we're familiar with that. I think I'm a little bit, I don't know if it's falling off the edge of the screen. Also for law enforcement, again, they have similar needs. They're doing investigations of evidence and looking for connections. If you think about, in Hollywood, they have the kind of evidence board where they have pictures of different criminals and like they have like a Polaroid and there's yarn connecting them, right? They're kind of building a graph, right? But hey, if I work for the NYPD investigating gang activity or something, and Joe works for LAPD, and I want to share my graph with Joe, am I going to take a picture of it and email it to him, right? Something like this would let you collaborate on that sort of thing over the internet. Financial analysts, looking for fraud, looking for different things like that, might want to use Lumify. And also just like basic generic research staff, someone working for a law firm, perhaps trying to, again, a similar kind of investigatory analysis where they have all different kinds of data. Sometimes they've got text, maybe they have video, images, maybe they have spreadsheets, all this kind of data that they want to combine together, fuse together, integrate into a common data model, ask different questions about it, do different analyses. Why would someone want to use Lumify other than the really cool features and the fact that really cool people are working on it? Well, first of all, it's open source. So open source as in Apache license, go to GitHub, download it, do whatever you want. So no license fees, nothing. Every single thing in Lumify is based on open source technology. So that's really cool. This is kind of the software stack that Lumify is built on. So at the foundation, you have Hadoop. We tend to use Cloudera's distribution of Hadoop, CDH4. But there's no special sauce in Cloudera that we're using. So if you've got Horton or MapR, or I think Microsoft still technically has a distribution of Hadoop. Intel finally decided to quit, right? Or just regular plain old Apache Hadoop. You can use whatever you want. Elasticsearch kind of works at that level, kind of powering our full text search. It provides our search index. Running on top of Hadoop is Accumulo. If you're familiar with Accumulo, it's kind of like HBase, but slower, but with security. So it provides that really high granularity, cell level security. So every different record in Accumulo can have its own unique access control, which is really important for a lot of the customers in this town who have, law enforcement, different kinds of classification that they want to control their data. So that's, usually a must-have to support a lot of the customers in this town. Running on top of Accumulo. Accumulo is another tool that Altamira built. So the code, the stuff that's in gray is third-party open source. The stuff in blue is Altamira open source. Secure Graph is sort of a graph database layer that runs on top of Accumulo and provides cell-level security, visibility strings, access control, and Joe's going to be talking about all that a little bit. On top of that is Apache Storm, which powers our ingestion pipeline. So as new data is coming into the system in a streaming way, a Storm topology handles that, ingests, enrich, indexes all that data, and adds it to the data set. And then the 6 things on top of Storm are just a sample of different analytic tools that process the data, extract and enrich and index and do all these cool things to the data that it's coming into Storm. Quickly left to right, the first 2 are ones that I'm going to talk a little bit more about in a second. OpenNLP is an Apache natural language processing toolkit in Java. Does things like entity extraction, different things like that. Claven takes the output from OpenNLP a step further. That's the geoparsing tool that then takes the names of locations and turns those into geospatial objects. So it gets Springfield and it figures out what Springfield means in the real world. OpenCV is a computer vision tool. That's doing facial detection. So if you want to come by later, I'll show you some of the stuff we're doing, analyzing images and finding faces in images and letting you link that to a person. Tesseract is an OCR tool, optical character recognition. So that's getting text for us out of images, out of video, that sort of thing, so we can do some more processing with it. CMU Sphinx is a speech transcription tool. So another open source tool. It takes audio, right, a WAV file of speech, turns that into text, or at least tries to. Then we can do some processing on that. And FFmpeg just does some video analysis that we need for some intermediate processing. And Lumify is everything that kind of sits on top of that. The interface, the user manipulation of the data, that sort of thing. So some of the features of Lumify, we already talked about Accumulo and the sub-level security and everything that the Secure Graph provides. So every single piece of information stored in Lumify can have its own unique access control. So everywhere you see a lock on this diagram is where you can have another specific access control. So the fact that El Chapo exists can be unclassified, and maybe his birthday is secret, and something else is top secret. And the fact that he's connected to that company is only law enforcement can see that. So all these different completely ad hoc or arbitrary controls, access controls on who can see the data, who you can share it with, that sort of thing. So all of that is, and Joe will talk about a little bit more about how we accomplish that. So not only is Lumify open source, it's also something that Joe and I are paid to work on. So it's not just someone worked on a piece of software over the weekend, decided to open source it and donate it to the world, and it's kind of abandonware that's just out there. Lumify has paid developers who are paid to work on it, add new features, fix bugs, that sort of thing. So there is a company, a commercial enterprise that's actually behind Lumify pushing forward and paying Joe and me to come talk to you tonight about it. I mentioned before, the demo you saw was running on AWS. So it's on the Amazon cloud. So that's really cool, right? You don't have to install anything whatnot. You don't have to have your own data center. You don't have to install anything on your machine, so your account will follow you wherever you go. You just log into the AWS site. But so enough about all that. At least half the people in the room are here to hear about how we use NLP inside of Lumify. So that's what I'm going to talk to you a little bit about right now.
Hey Charlie, do you want to wait till the end for questions, or?
Oh yeah, if you've got questions right now, I'm happy to answer them.
I've got a quick question.
Yeah, go ahead.
Can you just describe the distribution of data between the front end and the back end? So like if I'm doing a query and I'm looking at a person, I want to see the links out to other things, what part of that data exists at the browser, what part's in the intermediate layer, behind some kind of an API, and what part is queried live back to the data store? Well,
nothing kind of lives in the browser, right? The browser is just doing the front end visualization. All the data resides in a cumulo in the cloud, right? So you're only pulling down the data as you need it, right? As I pull up the view of somebody, as I open those documents, that's the only time that the data is actually coming into my view. I'm not sure if that.
Well, so like if I click on a particular node and I say, show me all the related entities of this type, right? You're going to go back to the back end and do a query and look for those. And how does that query, I mean, at what point does it start to break down in terms of graph size, number of nodes, number of edges?
I don't know, Joe, if you want to tackle that?
Yeah, I think we'll get a little, let's take that question, and then after I cover my secure graph, then we'll revisit it.
Most of it's in the core of secure graph, is that
yeah.
Okay. All right.
So we'll put a pin on that, we'll get back to that. Any other questions at this point? Yes, sir.
You said it's all on AWS. What would you estimate the daily or hourly cost is of running basically what you have right here?
Again, it depends, right? So something this small actually can fit into a single node. Like with the amount of data that I have for this demo, I can run that locally on a single machine. So I don't really need AWS for this. But we have another demo where all of Wikipedia has been ingested just as another demo data set.
Right.
I don't pay the bill for that, and I don't know if you know. It's not. Yeah, it's a lot cheaper than running your own data center.
Yeah. No, I realize that. It's just it's a lot easier to say we should do this when the cost is going to be X per day.
Sure.
Yeah,
well, and depending on the kind of needs that you have with AWS, I mean, if you are using it to host a software as a service kind of thing, that you're always keeping the lights on, that's going to be a different kind of equation.
Right.
If you're just doing it for raw compute power, there's something you can take advantage of called spot pricing. I don't know if you're familiar with that.
Yeah.
For anyone else, it's essentially, there's like a market for compute cycles on AWS. And as you might imagine, if you need to get it processed right now, then you're going to pay whatever it costs right now. But if you're like, I don't care, as long as it gets run sometime in the next week, you can set up something where it watches the price, like the minute-by-minute price, and when it dips, that's when you go and buy your block of time on AWS. So you follow that spot pricing and take advantage of the dips in the market, essentially, to maximize your dollars.
And I think the biggest thing that drives something like Lumify is how fast and how much data, like your hose, is coming into it. One of the connectors that we have is like for a Twitter feed. And so we can actually monitor, like, say, 100 different accounts and whatever. The ingest speed is probably the most driving factor of how far you need to scale out. As far as like storage, that's a different scaling factor. I mean, there's kind of a couple different ways that you can scale and slice and dice the problem. But if you're looking for slow ingest, then you can probably scale it smaller.
I was actually curious because I mean it's not exactly a big data set, but
for this demo, definitely not.
Really fast. And so like a lot of things, if you were trying to do this on relational, I mean,
it's just, you're right.
It's going to be painful.
No, absolutely.
Well, and the cost also depends on, how many concurrent users do you want to support? If you want to support 5, 50, 500, 5,000, that's also going to be part of the equation too.
Yeah, I mean, like I would say probably one of the bigger data sets that we've just, in development and playing around is definitely like the Wikipedia. So we just downloaded the whole Wikipedia thing, took every one of the links within a document and made them edge. And you can do things like start at Apple and go to Google and find paths between them, and it's relatively fast with like I think we tried that with like a 5-node cluster, and we got the ingest times down to probably less than, like 4 or 5 hours to ingest all of Wikipedia.
All of the English language Wikipedia.
Yeah, and get
build
it back
to build
into
that
the
out.
system, so.
And if you want it faster, add more nodes.
Yep, add more nodes. Yeah, we scaled it up to 10 one times, and it didn't quite linearly scale, but it
well, interpolating from those 2 points, it was roughly linear.
Yeah, that's right. Sorry, but it was not twice as fast. Yes, it was definitely not twice as fast by adding twice the number.
And since I have no way to frame, how many terabytes and how many nodes is Wikipedia?
Oh.
Wikipedia actually isn't that big.
Just why, not why I was asking.
It's not ginormous.
Are you guys doing the images too, or just the downloads?
Just the downloads. It's not.
I'm just saying, to get a sense, you need to frame
absolutely.
a set of
that's in like
something.
the hundreds of gigabytes.
Yeah, I think it is like 120 gigabytes, something like that.
And then once you add pictures and stuff, that would absolutely.
And it was and that was zipped.
Gig and,
so it's like 100 zipped, and then you unzip it. And, I don't know. We never actually treated it in unzipped state, but yeah.
So they have partials if you're doing some some prototyping.
Sure.
Definitely use the partials first.
Yeah.
Because
Oh yeah. No, absolutely. Yes. Yeah.
So you talk about connectors a little bit. Does it support any kind of APIs to existing commercial software?
You can, right, if you want to go in and write those connectors, but we do those sort of like as it's warranted, right? If someone's paying us to do it, then we do it. Otherwise, then we're going to typically work with free software. Okay. Anybody? Yes?
Can you calculate the different graph metrics that go along with each one of those nodes?
We can, right? So right now we're not doing so much of that, and Joe can talk about that in a little bit. So there's definitely a lot of room to grow. So if people want to get involved on GitHub and open source community and add, different graph metrics, graph analyses. There's a lot of NLP stuff, and I'll talk about at the end, sort of like what we plan to do. So there's always more that we can add. So, sir.
What kind of like a database or like a backend, like how do you store the data, like through the MS Access or like Excel sheet, or like how the data comes from the backend, like how do?
So the data is stored in a Cumulo, right? So when it comes to us, we shove it into a Cumulo. We'll essentially take any kind of input data that anything from unstructured text documents, emails, news reports, whatever, PDF, HTML, Word document, anything Apache Tika can eat, will eat. Any kind of structured text structured files like CSV, Excel, whatever, images, video, audio files, any kind of raw data, almost any kind of raw data file format that you have.
How do you migrate that data, raw data from?
Right.
Like
So that comes into a ingestion pipeline, which is essentially a storm topology. So Apache Storm, familiar with that? That's sitting there, and then I'll get into this a little bit where, depending on what type of data it is as it comes in, there's different analytic tools that are sitting there waiting to extract and enrich and do things to that data, index it, whatever, depending on what kind of data it is and what things you have turned on in your ingestion pipeline. But I'll talk about a little bit of that in a second. Yeah, all the data itself is stored in a Cumulo. It doesn't have to, right? There's, if you wanted to implement this on top of HBase, please pay us to do that. Or another sort of backend. It'll work with essentially, whatever you'd want to do to put the effort in to do that. But
so in structure, or maybe like you create the schema or Altamira, and like then you migrate the data from Excel sheet to the.
Essentially,
yeah.
And Joe, I think Joe's going to cover it.
We have for various demos, we have various custom input schemes. Like one was Twitter. It's completely different storm topology. The Wikipedia stuff is actually a MapReduce job that we run across the multiple gigabyte file, and it just processes it that way. So yeah, it just depends on the type of data and how we're going. We got Facebook queues and stuff like that.
Are you guys doing anything on automated link identification?
Yeah. So all of the links you saw initially.
Automated beyond.
Except the one that I drew myself was automatically added. Right. So because it came from a structured data set. So when you ingest a CSV file, whatever, right, it has rows and columns. Me as a user, if I want to be completely lazy and not sort of define anything about that document, Lumify will still eat that. It'll essentially treat that like unstructured text and do whatever it can with that. But me as the analyst, if I want to provide just literally like 5 or 10 minutes of effort and sort of tell Lumify what this data looks like and what I want Lumify to do with this data. And I say, okay, well, maybe this is these are customer records, right? And each row corresponds to a customer, okay? So every time you hit a new row, I want Lumify to create a new person entity. And these are what the columns mean. This is the first name, last name, this is the address, this is whatever, this is maybe, maybe this is a company that that customer works for. So if I see that company and it doesn't exist, I'll create a new one, or I'll just link it back to the one that exists, create that works for relation right there. So it'll build that right out of the text, or I'm sorry, right out of the structured data. On the unstructured side, it does all of that automatically for the locations. Because we trust the system a little bit more with how it can handle locations and doing the entity resolution on locations, it'll do that. It'll find those locations, link them to those documents, and say this specific, Springfield, Virginia was mentioned in this document. For people and organizations that are mentioned in that, you can provide a white list of known entities, like people that I know exist in this domain and I want to treat specially, and every time you see this name, you hear all the different variants of the names or aliases. Every time you see that, resolve that to this specific entity. Otherwise, because with open domain entity extraction and resolution, on people and organizations, we don't trust it, right? Because how many people named John Smith are there in the world? We don't want to say they're all the same person. So it'll just highlight that and requires, and the user will see that sort of highlighted in the text, and then they have to come along and do that last step of confirming and validating and linking that to the specific entity. So it's a combination of both.
My question was, how do you deal with disambiguation when you have, like Springfield, for example?
Sure. With the geo stuff, that Clavin tool can handle that with pretty decent accuracy. For the people and organizations, for open domain stuff, right? Literally any website on the internet, there isn't a tool that can do that really reliably. So the machine will do kind of the first half of it, find it in the document, say, I think this is a person, this is the name, and then the user has to say, like, which George Bush are they talking about here, right? So say, okay, these George Bushes is all Bush 41, these George Bushes are all Bush 43. Same thing like different versions of the same name. So President Obama, Mr. Obama, Senator Obama, Barack Obama. The user has to come along and say those are all pointing at the same actual thing. So it's a combination of both the human and the machine working together. Because like I said before, the machine's really dumb, but really fast. And the human's really smart, but really slow. So by getting them kind of working together, doing what they're best at. So, all kinds of questions, that's great. Sir?
Does it consider timeliness information, any of this? For example, documents,
Sure.
Let's say you're dealing with
We're not doing too much with temporal analysis yet. That's on our roadmap. We've just started to do a little bit with geospatial stuff, and we'll get to temporal eventually, but
So connecting to the traditional world, if I had a relational database that had a perfectly kosher entity relationship enterprise model, do you have the connector to pull that into your graphical setup?
Depending on what type of system it is, yeah. I think we do some stuff with MySQL. There's a couple of different things that...
I mean, right now we're actually working with one customer right now to build a web service connector. So they already have a service that you ask it, hey, here's a vertex, give me all the related things. They already have web services around there. And so we're building a connector right now to actually connect with them, which will surface all the way up through our middle tier, do the analysis, and actually to the front end. So we're actually kind of souped up. So it's just, yeah.
Well, I mean, so you got anything like an ODBC connector, or?
No, not right now. Yeah.
Yeah, this is about 10 months worth of work, the relatively.
Okay, no, it's really impressive, but it's sort of like, boy, I could really knock up the user interface.
GitHub.com/Altamira/Lumify. Welcome contributions. Yes, sir. I'm just kind of working this way, so I'll get. Yep, go ahead, sir. No, you.
Yeah. So assume that I have a data here, and I want to use your tool.
I'm sorry, I didn't catch the first part.
Assume that I have a data in the Excel sheet.
Okay.
I want to use your tool. What skill set I need to know to use your tool?
Eventually, as a user, literally, eventually, once all the user-friendly wizards and everything, it will be point-and-click kind of stuff, right? So if you've got an Excel spreadsheet, eventually there will be a wizard where they'll say, here's a snippet of what your data looks like, kind of like when you are in Excel and you're importing a CSV or a text file, right? And you want to define the different breaks are and that sort of thing. It'll be like that where it'll say, okay, tell me what you want me to do with each row, what does each column mean, map it to the ontology. So it will be eventually very user-friendly. Right now, at this point, to do all that, you kind of have to edit an OWL file and edit a JSON config file to do that. but eventually there will be essentially wizards that allow, French history majors to do that kind of stuff.
Yeah,
you don't have to be a pro. Yeah.
Do you have an ETA for that? When I can see the result?
When is it going to be done?
Yeah.
Subscribe to our blog or Twitter, and you'll hear the updates as they come. Yes, sir. Back in the corner.
Is it built to ingest unstructured web data right now, so you can point to a web page?
Yeah, it'll take HTML files, whatever you have.
Extract out the main body of it. It'll extract out the titles
So,
and various things like that.
There's a tool called Apache Tika,
Part of the way there.
which uses like boilerplate, beautiful soup. All these different tools will take a website and it'll strip out everything that looks like navigation and ads and just kind of get you the meat of the content and allow you to do your processing on that.
Yeah, how flexible is the architecture? So it seems like those bottom tiers are very specific to
actually, every single thing here could be swapped out, right? So, except for secure graph. Okay. So, well, you could use a different Hadoop, and maybe with enough effort, you could even get rid of Hadoop. This could be replaced with Lucene or Solar or, God forbid, Microsoft Fast or something like that. We've run it on stuff other than Accumulo, but again, this requires effort to kind of reconnect it. Storm, if you want to use Spark or maybe just MapReduce jobs on HDFS, you can do that. Every single one of these here are all pluggable, right? So eventually, and I'll talk about this in a second, OpenNLP is not the only open source entity extractor in town. It's not even my preference. You can use Stanford NER or even a proprietary tool, right? If you're a customer and you spend a lot of money on something like NetOwl or Metacarta instead of Clavin, hey, if you've made that huge investment and that's the tool you want, you can essentially kick these out and replace it with something else. And none of these are really absolutely necessary. These are just adding things, kind of enriching the data to make it more useful, but none of them are absolutely necessary. Anybody else before me? Cool. Okay, let's go back to, this is where we work. Okay, so this talks, and this is the first time I put this slide together today, so hopefully it's not too complicated, and I'll kind of walk through everything that's going on here. So this talks about kind of the first step before you can do NLP, before you can analyze the text, is you have to get the text, right? And there's a lot of different types of data that we're working with, so we need to have kind of creative ways of grabbing the text, pulling that out of the file to do things with it. So these 5 boxes here are kind of high-level abstractions on different things that we're doing with 5 different kinds of data. So we have regular text documents, emails, news reports, websites, PDFs, whatever. Structured data, that's like your Excel files, CSV, databases, whatever you got. Images, can be any kind of picture, whatever. Audio files, and then videos. And videos get a little more complicated. We'll kind of walk through what's going on here. For text documents, it's pretty simple. It gets run through Apache Tika. That kind of just grabs you the actual content. So if it's an HTML document, it gets rid of all the tags and everything and just gives you the raw text that's in the document that we want to work with. So we go from that text document to this output text that we'll deal with. Structured data, I talked a little bit about that before, how the user will be able to provide that mapping on what they want the operations to be done on the data as it's being processed iteratively. But at the end of the day, we get some text extracted from that. Maybe there's plain text fields in those cells or whatnot. So structured data isn't too complex to deal with that. Images. Anytime we get an image in this Storm ingestion topology in our ingestion pipeline, we run it through an OCR tool. Right now we're using Tesseract, which is an open source OCR tool, optical character recognition. What that does is it looks at the text, or I'm sorry, it looks at the image itself. It finds any text that it can find embedded in the image. Like if I save this as a JPEG, we try to find things like text extraction, text docs, looking for text that's actually in the image itself. Finds it tries to do OCR. You know, if you ever had a scan of a PDF and run that through OCR, it's not going to be perfect, right? It's never going to replace a human reading it, but we're trying to do things that scale, right? Having millions of documents, a human's never going to read all of them, millions of images, try to pull out the text that we can with OCR, and then we'll do some of our downstream processing with that. Yes, sir?
So if you had an image of an automobile that contained the license plate.
Yep, let me actually show you something what I'm talking about. So I still have the demo running and I'm still logged in. So here is what I'm talking about. So let me pull up an image, like right here. So this image has a bunch of text that's in it. Like you can see, Espargoza Moreno Network. So this is some kingpin, right? All the people who work for him, companies, U.S. Department of the Treasury. So down below, this is all the output from the OCR. So again, it's not going to be perfect, right?
You want to show the first thing, which is the faces?
I'll do that in just 1 second. So the OCR goes through and like here it pulls out Foreign Narcotics Kingpin Designation Act. So you got office wrong. It says OFLICE. So it's not going to be perfect, and it's not going to replace a human actually looking at it, but it's just good enough to make it useful. So now if I search, right, if I did a search for Foreign Narcotics Kingpin Designation Act, I would get this image back in the results. Right? So I'm able to do a keyword search and get images back based on the OCR output that's been extracted out of it. What Joe was just talking about before, the OpenCV tool that was in the stack does facial detection. So it's essentially an algorithm that looks for the most part, 2 eyes, a nose, and a mouth, looking for faces in images. Just like the OCR looks for text in images, this looks for faces in it. It's not doing true facial recognition, which requires like training examples. Like I would need a couple dozen pictures of Joe for it to find a picture and say, hey, that's Joe. Like iPhoto can do that, and I think at some point Facebook has been playing with it. But it will say, hey, hey, I found a face down here. So it says it's found 7 faces. Some of them are wrong, right? This one here is not a face. But it's got that one right there. So I can click on that and say, hey, I know who that guy is, right? And add his name in and make that connection. Let me see if it actually got the guy at the top. The guy I actually care about. Yep, got him. That is Moreno. So that's Juan Jose Espargoza Moreno. So I'll resolve him. And so now I actually have, instead of just it says face, right? It has an actual link to the entity that's part of my investigation. So we do the OCR on the images to get some text that we do in our downstream processing. For audio, we try to do automatic speech transcription. So there's a tool in Carnegie Mellon called Sphinx. That's an open source automatic speech transcription tool. So you provide it with an audio file. Hopefully it has people speaking. Hopefully it's in English. And it will go through and try to automatically turn that audio file into text. Again, just like OCR, it's not perfect. It's not designed to replace a human actually listening to that audio, because the human's going to be much better. But it's right just enough to be useful, right? So it'll pick out things that someone said. Like there's an example I can show you in the demo if you want to come by later, where we have, and these are like fake audio files where, I don't think Joe was actually on it, but me and some of the other guys were like pretending we were these kingpins, like, oh, we're gonna meet outside the U.S. Embassy or whatever, right? Pull out of that and say blah blah blah, U.S. Embassy. So now you can search, and it'll say here's an audio file where they mention U.S. Embassy, right? So it's designed to increase the discoverability and help you find that information, right? It's never going to, at least not anytime soon, replace the actual computer. So anyway, so just like the images go through OCR to pull out text that we process later, audio goes through CMU Sphinx, the speech transcription tool to give us text that we process later. So all this on the bottom is video. And it's actually not as complicated as it seems. So what's going on with video, the raw video files come in, we transcode them a little bit with FFmpeg, which is another open source tool that does video transcoding, video processing. We kind of break it out into 3 parts. So the video file itself, there's a tool called CC Extractor that pulls out any closed captioning, right? So that's kind of cheating. So there's text that's kind of embedded in that video file. We'll pull that out. Maybe it's, because like sometimes on YouTube you can have closed captioning or whatever. There's closed captioning embedded in the video file. So we'll pull that out, turn that into text, and stick that into the text representation of the video. Just like we did OCR in the images, we're going to take that video and break it down frame by frame. We'll like sample every 5 frames or every 10 frames, whatever. You can configure that. The smaller you go, the longer it takes. But so we'll look at those frames, and we'll, just like we did with the images, we'll try to pull out text out of those frames. I'll show an example over here real quick. With in the demo, I'll go back to my search, go to video, pull this one out here. Where is Oh, here we go. So here's a video frame where there's text in it. So the OCR tool stopped in that frame, looked at it. And again, it's not perfect, but it's pulling out some garbled text, but there is some stuff that's right. And again, over the years, these things will get better, and there are non-free tools that are more powerful. So in an actual customer environment, they may choose to say, hey, OCR is really important to me. I made a big investment in this huge, really expensive proprietary tool that costs $1 million a year that we're not going to pay for prototyping. But a customer may have made that investment, so we'll kick out Tesseract and replace it with the OCR tool that they have. So going back to video, again, so we pulled out closed captioning. We looked at the video frames, treated them as images, pulled out any OCR text from that with OCR. And then for the audio tracked in the video, again, we take that audio, run that through CMU space, and output that. So Joe will probably say, hey, Charlie, we're not actually doing this little part just yet, which is true. We haven't turned on the downstream NLP processing of the text output from CMU, but that's coming in like a week or two. So this is a high level kind of where the text comes from that we're going to start processing with our NLP tools. So again, it comes from 5 different sources: text documents, no duh, structured data, CSV files, Excel, what have you. Images, we pull OCR, we use OCR to pull out text from the images. We use a speech transcription tool to pull out text from audio, and then we do a couple different things on video. Any questions at this point with what's going on here? Yes, sir.
Yeah, how much metadata do you have to have in order to process your structured data? So
as little as nothing, but the more the user or the owner of the data provides, the better it gets. So like I was saying before, if the user doesn't want to say anything about the data, Lumify will still ingest it, but it won't be able to do much more than treat it as completely unstructured, right? So there's, like, if you have that customer record thing, it'll still go through that and it'll try to find names and locations and that sort of thing.
So in order to generate your demo that you did, and do you store it in, how do you store it also, the metadata?
Joe will talk about that, the storage of the links that define all those edges.
Oh, yeah. I mean, what's the source? Is it a text document? Or
the input was a CSV file. It was essentially an Excel file saved to a flat text file.
Oh, of your metadata that you use to process your stuff.
Oh, it's a JSON file that defines sort of the operations that I want Lumify to do when it reads through. So that JSON file might be half a page long, and then you can have 1,000, 10,000, 1,000,000 records, and that sort of, you can almost think of it like a macro where Lumify will follow the rules provided in this JSON, which correspond to things in the ontology, and it will go through and every time it sees a row, it will create a new entity, and maybe link it to different things depending on what the data says. So, yes, sir.
Is this the next big thing for?
I think so.
Okay. You know how people like to Google their friends? It seems like you could use Google to get a whole bunch of documents, and feed them into this thing, and enhance this whole experience.
You could. There's been a lot of search engines have tried to do that. Commercial search engines have tried to do something more complex or more advanced than what Google is doing. I'm thinking of things like Clusty, different things like that. They've all been complete failures. And I think not because of they're not valid from an information retrieval, whatever thing, doing some really cool stuff. But your average person just wants to type words into Google and get their top 10 results, and they want those top 10 to be as relevant and as well, and coverage in the IR sense, covering all the possible fields. Doing things like clustering different sets and trying to pull out stuff. I think maybe eventually that there will be users may want that. I mean, me personally, I would want to use a search engine like that. But from a completely open domain, commercial Google type thing, there hasn't been much. There have been a lot of experiments like that. There hasn't been much in terms of user adoption for that sort of thing. Sir?
Yeah, the question I have for you is that you're doing text extraction, so you normalize each one of these different types of inputs into text itself. Is it possible to normalize it to something else to do correlation between the different type of information here?
Sure, yeah.
Some type of metadata so we could do.
There's a lot of other processing we're doing. I'm kind of just focusing on the text stuff, but we process the images, we do different things with the images, and the video, and the structured data. So I'm just kind of covering the basis for what we're doing with
Do some
text.
type of data analysis of some of that information.
Yeah.
Let's get other type of information, look at correlation.
Absolutely. We're not doing too much of that right now, just because, again, 10 months with a small team, you kind of knock out what you can. But yeah, that's definitely something that we'd like to.
But of course, add additional fees in here too. Maybe you select 5 of them.
Mm-hmm.
We might have others too that we
Yep.
also add to it.
Absolutely.
Okay.
Yeah, absolutely.
Thank you.
Sir.
So you show that where you have to manually tag objects and entities. I mean, is it in the roadmap where you would automatically, at least 80%, guess what's about it?
Yeah. So and that's configurable, right? So if you, as the user or as the customer organization, if you trust the output that you're getting from the entity extractor, you can turn that on, right? And say, I don't want to have the extra step where the user has to go in and validate that, right? But that requires a bit of a leap of faith right there, is that you're going to get a bunch of false positives, right? State of the art, on clean English text like news reports, getting F measure around 0.9, which to me is awesome. But anytime you start introducing, well, we're not just looking at news reports, we're looking at emails. We're looking at Twitter, whoa, that's really bad, right? So, a lot of the decisions that you're going to make in the implementation and configuration depend on how sophisticated your users are, what kind of data you're working on, what are you trying to get out of it. So there's a lot of flexibility with what you want to turn on and off and how you want to handle things.
Do you have like any step guide how to use it from start to end, like a configuration, installation, and like a...
Not exactly. So there's some documentation. There's a VM that you can download and stand up. But it's not the easiest thing in the world to get up and running. You need to have some programming knowledge and be able to, edit config files and do command line utilities. So it's not.
It's like we have the instruction to do that.
We have some of it.
Some of it, yeah.
It gets better.
We write code, not documentation,
Yeah.
right?
Some days it gets
I'm
better.
sure you guys can all relate to that.
So I do stuff with the entities, and sometimes you have ambiguous around, like for instance, aviation, you have waypoints and things like there are some that are called check, is could be a word too. So you use like for instance, evaluation or some sort of machine learning to do anything like that.
Not yet. So we're kind of just doing, on the first pass, just doing named entity recognition. So pulling out essentially proper names of people, places, organizations, that sort of thing. We could, at some point, add a tool to do something like that. Liz has actually done some work on that sort of thing, extending Klaven to work with military equipment, weapons, that sort of thing, that combine machine learning with kind of a white list of known entities to kind of do that. But that would be sort of like, Lumify is designed to be like a 60 to 80% solution out of the box, and then to get it specific to a customer user's mission, you want to pay us to customize it. Excuse me. Any other questions before I move on? Sir.
Kind of related to what you were just talking about, in terms of, it looks like mostly you're targeting a self-contained end user application, mostly, with the ability to add in some things. But so the question for me is how open and available are the abilities to customize and enrich certain areas of the application going forward? What is your philosophy?
All open source, so anyone in this room who wanted to tonight, get really excited about this talk, go home, go on GitHub, pull down the source code, play with it, add something and contribute back. So anyone who wants to, we will validate and check that code before it gets merged in. But anyone who wants to can make contributions to it. It's not just designed for a single user. We don't have another screen, but like Joe, if he wanted to, could log in to my instance. I could share things with him, and we can collaborate on real time on a single investigation, kind of like Google Docs where we're editing things together. So it's designed for collaboration. So it's designed for an entire organization doing different analyses on the same data set. Anyone else before I move along? Joe's chomping at the bit over there. So very quickly, two of the big tools that we use for NLP in Lumify are Apache OpenNLP and Klaven. So Apache OpenNLP is an open source named entity recognition tool. It's not the best thing in the world. I can see Ben kind of groaning, right? It's not my favorite NER tool, but it's Apache licensed. It's a permissive license. It doesn't have the viralness of the GPL like Stanford does. But anyway, so putting that aside, what a named entity recognition tool does, it's essentially an entity extractor. So it goes and finds names of entities in unstructured text. Generally, the way these tools work is they have models that have been trained on machine learning. So some poor grad student was chained to a desk for 6 months at a time. I've been there, Ben's been there, I know. Going through and manually annotating and marking, this is a person, this is an organization, this is a location, whatever. Marking that all by hand, it's really monotonous, boring work, but you produce this training data that you can run your machine learning algorithms on, conditional random fields or whatever you got, to essentially learn a model that then takes new text and is able to automatically tag things as people, organizations, locations, whatever. So they're not using a big white list of known proper names or anything like that. They're essentially working on the syntax and grammatical structure. So if you might imagine a sentence like, I went to X, whatever X is, it's probably the name of a place. Like that's a really simple kind of example, but you can start to see things like that. Or my wife's name is X, right? Kate, probably the name of a person, right? So things like that are what it kind of, and it tries to do that disambiguation. What, like, you know, there's how many different, there's like 36 Springfields in the international law that you can't have 2 different towns with the same name. I live in Round Hill, Virginia. There's there's 3 towns named Round Hill in Virginia. So it tries to solve that Springfield problem, figuring out which is the right one. So it has some heuristics and different ways that it tries to solve that. And one of the big things it uses is what other locations are mentioned in this document, right? So if you see Springfield in the document, you're like, well, which Springfield is this? But it also says Boston. That's a big clue that you're talking about Springfield, Massachusetts. But if it doesn't say Boston, maybe it talks about Chicago, that's a big clue that you're talking about Illinois. So that's a really simple overview of kind of what Clade does. It lets us disambiguate place names. It essentially turns text documents into maps. And I can show, if we want to later, kind of running out of time, some of the map stuff that we're doing. Going really slow. Okay, so at the end of the day, this is kind of what we get. With our text documents, we get locations that are highlighted, we get people, we get all these different things. It's a combination of both the machine and the user going in, adding things, extracting things, resolving things. So you're getting both the human and the machine. So what are the benefits of this, right? Why are we doing this? So the first thing it does is it increases the discoverability of our text, right? So we're not just doing bare keyword searches. We're able to look for different entity types, different things that are in the data. We're able to link different things to people, the documents that people are mentioned in, that sort of thing. Which documents, or which people are mentioned together in which documents. Helps us deal with information overload, right? If you're a user and you've got millions of documents to analyze, you were never going to sit down and read a million documents, right? How many pages can you read an hour, right? There's no way for you to cover all of it. Even a large organization, right? If you have 500 analysts, they're not, even all together, they're not going to be able to read everything. And even with that, now you have 500 different silos for where that information resides. So we want to be able to process all of that data. And yes, the machines are dumber than the humans are, but the machines go faster. So the machines can do sort of a shallow analysis on everything, and the humans can use that to sort of be the jumping off points for where they want to dig deeper and actually put human eyeballs on the data. And this helps us find, uncover hidden connections, different associations of sort of unknown unknowns that we didn't even necessarily think about. Kind of the difference in my mind between search and discovery is, like, search is you're playing Battleship, like the board game Battleship, where you're firing these random keywords over the wall and saying, B6, nope, there's nothing there. A11, nope, there's nothing there. So you kind of have to, or at least know what you want to look for before you're able to find it. Versus discovery, it takes that wall down and lets you look at, sort of all the data in aggregate and say, hey, all of the ships are kind of in the corner over here. I never would have even thought to look over there. So anyway, so some of the future stuff that we want to do real quickly before we get to Joe's part. Me personally, I can't wait to get rid of OpenNLP. I want to use different entity extraction tools. Stanford NER is an old reliable one, but that's GPL license, so you got to jump through to deal with that. Mighty is a new one that actually Joe found the other day. Is like MIT information extraction, sponsored by DARPA, recently open source, has a lot of promise. It's supposed to be as good as Stanford, but Apache licensed. Or is it Apache licensed or Boost? Is it different, a permissive open source license? So that's pretty cool. SU time is another tool from Stanford. It's like Clavin, but for temporal expression. So it tries to find, you know, Wednesday 14th, 1987, right? Or last February, right? And we'll attempt to normalize that and tell you what that means. So like a document written 2 weeks ago, it'll tell you what yesterday meant in the context of that document. We want to do some event and relationship extraction. One tool we'd like to integrate is called OpenIE out of the University of Washington. Why they renamed it OpenIE when they're in Washington makes me think it's a browser. But that's actually open information extraction. Used to be called Reverb and had another name before that. Want to do some stuff with co-reference resolution, which will help us figure out, you know, which George Bush is this George Bush? Are all these different Obamas, are they talking about the same person? I have some ideas about gating in Annie. So Annie's co-reference resolution library kind of inside of Gate. Gate's an old NLP tool from like the 90s at the University of Sheffield?
Yes.
Sheffield. Gate is really getting old in the teeth, but I have some ideas on how to kind of resurrect it and go in different directions with it. Harebrained schemes. We want to do some more text analytics, just some simple frequency analysis, top 10s, that sort of thing. Do some topic modeling, maybe go crazy and try some sentiment analysis down the road, and then eventually get out of just English and do some other sub-tool too. These different NER tools provide different language models. Stanford does, or tries to do Chinese, German, whatever. And there's another tool, I believe, for Python called Guess Language that attempts to determine which language a document is written in. So with that, I'm actually going to transition over to Joe without further ado.